Hello everyone. This is Professor Akshay Dekne from South Sundarbai Manik Arsur Polytechnic, SAS Ahmednagar. And today we are going to study a topic from Advanced Manufacturing Process of third year Mechanical Diploma students. And the name of topic is Electric Discharge Machining. That is EDM. So what is meant by EDM? Whenever sparking takes place between two electrical contact, a small amount of material is removed from each of the contact. This fact is used to produce sparks between the tool and workpiece. It is also known as spark erosion, electro erosion, or spark machining. Actually, EDM is the metal removing process with the help of electrical contacts. Now see the principle of working of EDM. In this diagram, we'll see a DC supply and a tool. At the bottom portion we have workpiece. In between the tool and workpiece, a dielectric fluid is present. We can call the whole gap as spark gap, which is used to produce spark. Here ionized fluid is shown. Heat energy generated by spark is used to remove material from the workpiece. An electric spark gap is generated to machine the workpiece to produce the desired shape. The tool and workpiece are separated by a small gap called as spark gap. The gap varies from 0.01 mm to 0.5 mm. When supply is made on, thousands of sparks are come in contact with dielectric fluid in the spark gap and fluid gets ionized. It allows current to flow between the tool and the workpiece. Here, a very high temperature, near about 10,000 degrees Celsius, is generated in spark region. As a result, the material gets melted and is removed from the workpiece. In short, what the principle says, we have to remove the material from the workpiece with the help of tool by using heat energy which is produced by spark. First of all, heat energy is produced, then electric spark is generated between the tool and workpiece, and this spark gap is very small. So when electric supply is turned on, then spark come in contact with the dielectric fluid and fluid gets ionized. So the current flow between the tool and workpiece, which produce a high temperature, and all these things are result into the melting of material and removing of material from the workpiece. This principle is used as EDM. Now see the setup of EDM. This setup consists of four major components. First one is tool and workpiece. Second, dielectric fluid. Third one is RC circuit, and fourth one is tool feed mechanism. In this diagram, here DC power supply is given, then servo system is also provided. One container is there. We can say it as a reservoir. In this reservoir, dielectric fluid is filled. A filter is provided over here, and pump is also there at the bottom portion of reservoir. Power supply is connected to the tool which is having negative terminal, and positive terminal is connected to the workpiece. So this is the setup of EDM. For fixing the workpiece, a fixture is used. First component is tool and workpiece. It is kept in the reservoir and is connected to DC power supply. I already told you that tool is connected to negative terminal, that is cathode, and workpiece is connected to positive terminal, acts as anode. A dielectric fluid system, a reservoir is filled with dielectric fluid. It is continuously flushed into the spark gap, and the dielectric fluid used may be kerosene, may be paraffin oil, may be transformer oil, may be lubricating oil, or you can use distilled water as dielectric fluid. One major component is a RC circuit. A resistor is connected in series and capacitor is connected in parallel, which combinedly called as RC circuit. When the supply is made on, the capacitor voltage starts rising continuously. When capacitor voltage is equal to breakdown voltage, then spark discharge in the spark gap. After capacitor discharge, sparking ceases and dielectric fluid in the spark gap gets deionized. So capacitor is then recharged and cycle repeats itself. Tool feed mechanism. Since during operation both the tool and workpiece are eroded, it is necessary to feed the tool continuously towards the workpiece. This can be achieved by a suitable tool feed control mechanism along with servo mechanism system. Now, advantages of EDM. Any material can be removed irrespective of its hardness with the help of EDM. Any complicated shape can be produced. Very fine holes can be easily drilled. And there are some disadvantages of this also. The metal removal rate of EDM is low and power consumption is high. Application of EDM, it uses in making stamping tools, forging dies, etc. Also in micro hole drilling, in resharpening of cutting tool and broaches. So in this lecture we have studied what is meant by EDM, its principle of working, the components of EDM, that is setup of EDM, the function and working of each component of the EDM, advantages, disadvantages and application of EDM. All these things we have covered in this lecture. Thank you, student. Thank you very much.